Have you ever been on a plane, looked out the window, and just wondered, how is this giant metal tube actually staying in the air? It weighs hundreds of thousands of pounds, yet it soars through the sky like a bird. Well, it's not magic, it's just some seriously cool science. Let's break it down. It all starts with four fundamental forces: lift, weight, thrust, and drag. Think of it as a constant tug of war in the sky. Weight is easy. It's just gravity pulling the plane down. To beat gravity, we need lift. So, where does lift come from? The answer is in the shape of the wings. They're designed with a special curve on top, called an airfoil. As the plane moves forward, air splits to go over and under the wing. The air traveling over the curved top has to go a longer distance, so it speeds up. According to a principle discovered by a guy named Bernoulli, faster-moving air has lower pressure. This creates a pressure difference: high pressure under the wing and low pressure on top. And what does high pressure do? It pushes up. This upward force is lift, and when it's greater than the plane's weight, we get takeoff. But for the wings to generate lift, the plane needs to be moving forward and fast. That's where thrust comes in. Thrust is the force that propels the plane forward, and it's generated by the engines. Whether they're jet engines or propellers, they work by sucking in air and pushing it out backward with incredible force. For every action, there's an equal and opposite reaction. So as the engines blast air backward, the plane is pushed forward. Now we've got thrust pushing us forward and lift pushing us up. But there's one more player in this game: drag. Drag is the air resistance that tries to slow the plane down. It's the force you feel when you stick your hand out of a moving car window. Engineers work tirelessly to make airplanes as sleek and aerodynamic as possible to minimize drag. So, for a plane to fly at a constant speed and altitude, these four forces must be in balance. Thrust must be equal to drag, and lift must be equal to weight. So, the engines create thrust, which moves the plane forward. This forward motion forces air over the specially shaped wings, which generates lift. When the lift is stronger than the weight, the plane climbs. Once it's in the air, the pilot and the onboard computers constantly make tiny adjustments to keep everything in perfect balance. How do they steer this thing? That's where the control surfaces come in. You might have seen flaps moving on the wings during takeoff and landing. On the back of the wings, there are ailerons. If the pilot wants to roll the plane to the left aileron goes up and the right one goes down. This decreases lift on the left wing and increases it on the right, causing the plane to bank. The tail has parts that work similarly. The horizontal stabilizer has elevators that control the plane's pitch, making it go nose up or nose down. And the vertical fin has the rudder, which controls the yaw, moving the nose left or right. It's like a symphony of moving parts, all working together to guide this massive machine through the air. So next time you're cruising at 30,000 feet, you can look out the window and appreciate the incredible dance of physics happening all around you. It's a beautiful balance of thrust, lift, drag, and weight that turns a metal tube into a modern marvel of flight. It really is an amazing feat of engineering. Thanks for watching. If you found this fascinating, hit that like button and subscribe for more deep dives into how our world works. Fly safe.